Hi students, today's session is a quick recap of the formulas we learned in the chapter Current Electricity. The first formula we learned is I. I is the electric current and electric current is the rate of flow of electric charges. Q represents the charge. Charge is Ne. Q is equal to N into E, where N is the number of electrons and E is the charge of an electron. The charge of an electron is 1.6 into 10 raised to minus 19 coulomb. The coulomb is the unit of charge Q. I is equal to Q by T. When you cross multiply, what is Q? Q is equal to IT. Q is equal to NE. If Q is equal to NE, I is equal to NE by T. Substituting the value of Q. Therefore, I is equal to NE by T. Potential difference V is equal to W by Q, where W is the work done in moving the unit charge. Therefore, W is equal to V into Q. W is equal to QV. We learned resistance R. R is equal to rho L by A, where rho is the resistivity. Resistivity rho from this expression is rho is equal to RA by L, where rho is the resistivity, L is the length and A is the area of cross section. Epsilon, that is EMF or electromotive force of a cell, is W by Q. V is equal to W dash by Q. Small v is equal to W by Q. Epsilon is equal to V plus V. For better understanding of these formulas, please watch the video for EMF and internal resistance. Internal voltage drop is represented by the small letter V is equal to I into R. The small letter R is used here. Terminal voltage is represented by capital letter V. Capital letter V. Capital V is equal to I into R. Here you will use the capital R. The current drawn from the cell I is equal to epsilon by R plus R, where epsilon is the EMF of the cell. R is the external resistor and the small letter r is the internal resistance. The internal resistance R is equal to V by I, which is equal to epsilon minus V divided by V by R. This I is equal to V by R and the small letter V is equal to epsilon minus V, which is equal to epsilon by V minus 1 into R. Please watch the video for EMF and internal resistance to understand these formulas. We also learned the equivalent resistance for series connection as R1 plus R2 plus R3. When the resistors are connected in series, the equivalent resistance is to add those resistances. Whereas if two resistors are connected in parallel, how will you find out the equivalent value for that resistance? 1 by R is equal to 1 by R1 plus 1 by R2, which is equal to R2 plus R1 divided by R1 R2. This is 1 by R. Therefore, how will you find out R? R by 1. R by 1 is R1 R2 by R1 plus R2. The equivalent resistance when the resistors are connected in parallel is R1 R2 by R1 plus R2, and for series connection it is R1 plus R2. What is electric power? Power P is equal to rate of work done. Therefore, W is equal to P into T. But we know P is equal to VI. Therefore, W is equal to VIT. Power is equal to W by T. P is equal to VI. W is equal to VIT. We know P is equal to VI. But what is V? V is equal to IR. Therefore, P is equal to IR into I. In this place of V, you can write IR, which is equal to I squared R. P is equal to I squared R. Therefore, W is equal to I squared RT because P is equal to W by T. If V is equal to IR from the Ohm's law, what is I from that? I is equal to V by R. Therefore, you can substitute this value of I is equal to V by R. P becomes P is equal to V by R the whole squared R because P is equal to I squared R, which is equal to V squared by R. We can cancel one R from here. Therefore, W is equal to V squared by R into T. We know electric power is equal to W by T. Therefore, W is equal to P into T. We also know P is equal to V squared by R. P is equal to V squared by R. Therefore, R is equal to V squared by P. We also know P is equal to VI. Therefore, I is equal to P by V. While doing numericals, please remember when you find the cost of electricity, cost of electricity is equal to electrical energy in kilowatt hour into cost per kilowatt hour. In Joule's law of heating, we learned the expression H is equal to I squared RT. That is in Joule, and if it is in calories, it is 0.24 I squared RT. Thanks for watching the video. If you like it, please share with your friends. If you have any questions, please contact via email pjscracker@gmail.com.